Okay, nice. Hi, Ilnur. How are you? Are ready to start?
Yeah, I'm ready to start. Yeah, just fine.
Okay, cool.
Yeah, I'm fine.
Okay, cool. My name is Dmitry. I will be first. My question will be first. Then we will change our roles. I want you to ask this question. You have class not. Not has left, right, and next right fields, and also datum. So basically, you have a binary tree. And also for each node, you have additional, additional link to next right. Initially, it will be now. But
Initial pointer. Yeah,
yeah,
you mean?
yeah, it will be now. I want you to do this thing. I need you to fill it this pointer to the next right node. So, for example, you have. I hope I can copy it. Oh. Something like that. So you have this one, this one, and I want you to be it like that.
Now it means that I must, at this example.
Initially, it's all now. So initially, this now. So you don't really need to do something here. Here now, and also here, also now. What do you think? Sounds good? Did you understand the question?
Yeah. I have a question about the end of the node. For example, if we have empty right node at the end of our BST, should we fill it with null? Or
can you show me so I will understand your question clearly?
Okay, just look at the 412. Yeah. Here they have next right null. And they have value null. Especially if I want to put, for example, if I want to change value here, yeah, I should also put a null at the end, or nothing to change.
I didn't get where you want to put null. You mean this link?
Yeah. This link is for 2. Yeah.
Yeah.
I understand, right?
Yeah, right.
And
for 1,
okay,
it will be 2. For 4, it will be 1.
Okay, we shouldn't change values.
Not to value.
Okay, we shouldn't change values at the most right nodes. Yeah.
No, we don't need to change value. Value remain the same. I just want you to add link to next right node. So you have initially you have this one, 10, 3, 5, 2, 4, 1, 2. But I want you to link 4 and 1. So for value for link to next right for 4, it will be 1. Value for next right for 1, it will be 2. And for 2, it will remain null.
Okay, firstly, we should try to some kind of imagine of solution, or just to make a solution in example or logical explain or in explanations. So if we put 10 have initial root, has question about initial root. In this example, it is it is 10. So should we put 5, or just we need at the same level?
No, it's only level by level. So 10 doesn't have any right node. So next right node. So it will now. It will be now.
Okay. Initial root is 10. Has no right value. Has not right value on a branch. Then right node for 3, it will be 5.
Yep.
Going down for 4, it would be 1. For 1, it would be 2. And for 5, okay, it would be 2. For 2, it would be null. Yeah. So we should check about the 5, 1, and 2.
What do you mean check?
Because as the most right node,
Okay.
we should to make we should to fill it. We shouldn't change it actually.
Okay. Yeah. Right.
No. Oh. And okay. So firstly, which comes at my in my opinion, especially we need this is one. This is the solution. It is the FS with in order. So before we go down, we firstly check leftmost branch. Check it has if it has in the same level. If it has at the same level value, so then we going down until we find until trivial.
What is trivial? What do you mean? So you want to go to the most left node or most left
tree data. Tree data, yeah. So in my opinion, we should go for the whole tree. Okay. First of all, collect data by levels to understand that it is at the same level. And firstly, append the most left from the left to the right. From the most leftist to the most rightest value. And then
okay.
And then going down. First of all, we need to make like yes, we need to go down, like starting. I would be coding at Python language.
One second. Yeah, okay, in Python, it's okay. Small question regarding your solution. So
Mhm.
you're going to do DFS, you're going to traverse for whole tree, visit every node, and want to store it in data structure, right? And then
Yeah.
connect.
And then
Okay.
to try to put it. Oh, there's one problem. There's a problem that if I go, first of all, we need. There's one problem if I try first to collect and then to go down. It would be a little bit difficult in case in case that I need to remember all other things. So
What do you mean? What are the things you want to remember?
I need to remember that. Oh no, there's no problem. Okay, let's start for coding.
Okay.
How we will call. Let it be.
Small question regarding what time
Mhm.
complexity it will be if we are going to.
I think about list of list. Yeah, as a list of lists. Yeah, but now I thought about just to use simply an order to understand how I could change the pointer for the value.
Okay, in order, this is like you. What is it? I think it's in Python, some data structure.
In order, it is a way to work with DFS. It's kind of
I got it. Okay, in order traversal, I got it. Yeah. Okay, cool. Okay, let's start to code, and I will catch if I miss something.
Yeah, def. Let it be, I don't know. Right. We have an input tree node, and we should to return also node with data types. Yeah, we couldn't return anything else. So let's make an a helper function. I would create a REST as a result and return it as changed node. Helper, it is a helper function which helps me to iterate over my tree, and to find and create a new node which I will return.
Why you want to create new nodes?
Oh, just print, yeah? Nothing to return.
Even doesn't need to print. I think you can. Yeah, I don't think we can return like our root node, but it's not really necessary. I think we just need.
Just we could change and so on. It doesn't matter.
Yeah. Okay.
Tree. First of all, we need to check if we reach the end. And return tree because we reach the end and nothing we should change. Just simply. Oh my god. So we should also make a. We should know the level, because if we don't know the level, we could just make something wrong. Level, it means where the 3 and 5 on the same branches, but at the same level, but in different branches.
Okay.
So pass argument here. This int, this node. So
where are you going to put data about levels, or you don't need it?
I need it. Oh, I need also pass an array. Well, I need to pass a list to know that I have already data in leftmost branch. That I have data and they have a pointer. So I need to pass. Let's be L. And it would be a list of ints. So if level equals 0, we should firstly do recursion with no, it's a wrong idea, because if we recur a lot of time to append in array, we shouldn't mess and never get in touch with it. So if level equals 0, let's add the initial value, just to know that we pass it, and going, and also we could going through the other branches. So just we should recur here. Firstly, we recur left and then add to our array, because it is important to that leftmost would be at the level downer than the right, because we need to know that there's a left level. True left. We pass 1 and
why are we only doing it only on level 0, not on every level?
Because little 0 has left and right values. However, we should make sure that we have at the same. Oh, it might, yeah, that we have at the same level value, because we need to make a like in a list of lists, we should make like something like that, that it has value. So we should, because it's better to understand that we need to change next right. So let's show an example.
Okay, let's not spend time on example.
Okay.
Let's continue. So we'll see it.
Trade. Oh. Also levels, we should we should get value.
Why we are caring about value, not about not itself? Because not right, next right is not linked to not. Why we caring about value?
Because excuse me, could you repeat please the question?
Yeah, if you go up,
Why we could?
We have class not. Each it's basically not of tree, and we have additional next right. Next right is linked to not, so we need to next right will have a link to not value, so it's not integer, it's class.
Yeah, but there is one thing why we should to add values, because we need to know that most left element is in array. That left element is in array, and so if element in array and next pointer is null, so we could change the value of next pointer.
Can you show me an example? I didn't get it.
Okay, I will try. So we put the most right, the most left.
No, I mean on the tree. Can you show me on a tree? I didn't get.
Okay, on a tree. If we go first of all, the most leftist, yeah, we have a 3. So when we go down from the right branch, we understand that we have a 5. Yeah. So if we found out that 3 is not null and 3 is in array, so we could change next right row, next right node.
For free.
Yeah, for free.
How you are going to change something in next right if you in array you have only values, not you don't have access to it?
I would add just right. Yeah.
What do you mean? So you're going to find again this value and then link to it?
Oh, I need to remember. Yeah, I understand the question. I need to add. I need to collect roots.
Yeah, nodes. Right. Yeah, I think nodes will be much more useful than values.
Yeah.
Okay, cool.
So minus 1. Oh, just we should have here. We should make an checking if because we should understand that there is a value and that is not empty, right? Here we change right to the tree. Yeah, we change to the tree to our node, which is here. So next, if we initially comes to if initially we don't have the same levels, like
What?
in our array of oh, should make we could do like that. Find an error. Sorry. If it is smaller, so then we just add the most left.
One second.
Yeah.
We sorry for interrupting, but we don't want to have two-dimensional array here. We only have one-dimensional array with list of nodes.
Yeah. Oh, just sorry.
And how
for
levels helps us.
Yeah, it's 2 levels should be, because we should to understand where to iterate. Yeah. So
Okay,
here we changed. Yeah. And
how also about this condition? What does it mean?
It does mean that
okay, so we didn't what okay, got it. Okay, no problem.
Yeah. So Elsa, we just level, we just put a 3. So level and out string, string, yeah, string. So here we initialize new list and append to the list a new value. So after this, we need to understand how to iterate the next level. So if we pass it all, we should after this doing with our data. So if we should go into the most left and to the most right. So yeah. So we must, after understanding that we fill all, we should recur to the left node and right node for adding new level and passing array. So the logic of this code, we call here our helper function, which helps us to iterate in array. So we could iterate here. I use in order for having array of lists to
question. Yeah, I got what your idea. My question is, so if you check level 0, you also appending 3 data in your, so you're appending your current root, current node. But in else condition, it means you are adding only on level 0. You're appending your nodes only on level 0, or what?
Here, you mean, yeah?
No, I mean
when
here.
else
A little
condition.
bit up, a little bit up on first page.
Maybe. Oh yeah, we should to follow our logic. So we should add here the same. Yeah, it's my error. We should
Only.
add. We should add here to from the left to the right because we have iterate it over. So if we come to the node and for example we have here and we fill up with 5, yeah, if we add, if we comes from the right node here and we understand that in array of array there is a free node, yeah, with a free value. We change branch with a 3 to the 5. That's next right. and then iterate down here for the second. But however, if we are at the 3, we should to iterate down and add a new array for adding branches 4.
But how can you get to 5 before 4?
Because I have a level order here.
But it was DFS. So in your logic, you will go down to the leftmost road and then to the right, and you will reach 5 only when you go through whole left subtree.
Yeah. I have a problem with here because no, I don't have a problem because I check the length of the length of array. So if it comes 4, it would add a new array. Like here, it would be a new array with 3. Second, sorry. So it wouldn't mess with 3 because leftmost wouldn't mess with rightmost in case of the level order.
But you are not iterating through level order. You're iterating.
Oh no, I have because I put here just a level order like.
So yeah, you check that you already have it. In case you don't have, you still going left. So for your
no. I try to add. I'm trying to add this. Sorry. I understand the question because I forgot to add. Sorry. So we also going down because we add a new value. So we shouldn't take care about our level, about our previous level. Because if we don't have enough data, we would append new and new. And so if it's much smaller,
so basically,
I understand.
I got your idea what you're trying to implement and how. Probably we have some mess little bit with implementing here, but I think we are okay. I want to ask you one last question regarding space complexity and time complexity. And I think we can.
So it is a proper solution because I need to change here with logic.
What do you mean?
Okay. It's it's a little bit mess, but it's okay. Yeah.
Yeah. This one, let's leave it. I just want you to ask space and time complexity for this solution.
Space, time, it would be for the space, it will be big enough, I could tell, because we would time complexity, it is about n and n multiply m, where n and m is amount of branches in a n amount of left branches here, and m amount of branches here. And time complexity, it is the height of the tree. So it would be which biggest one, m or n, it doesn't matter.
Okay, and m. Okay, why? Why space complexity will be high of the tree?
Because we add the amount of masses the same as we going down through the tree.
But it looks like you're iterating through whole nodes and you adding it to your data structure map or to the dimensional list. So you will hold all nodes. No?
Yeah. However, we could make it less memory complexity with less memory complexity. If we just give if we use hash map instead of array of array. So
it will help you to save space.
Because hash map would have a structure like int level.
Yeah, I got this, but how it will save you space? You still need to store it.
Yeah. Oh no, it would be easier to read. Yeah, in my opinion, because sorry, for space complexity it would be also m and n because I add all elements and all nodes. Sorry.
What do you mean, elements and nodes? You mean links?
Yeah, links.
Gotcha. Okay, cool. I think we can stop here. Let's start. Let's go down and start in the end of the document. Yeah, I'm ready.
Yeah. So first I need to find the task.
Yeah, take your
time. Should I find some random task? Oh, sorry.
You didn't prepare?
No, I have one. Interesting.
Okay, sure.
Sorry. The task names we need to find free sum clauses. For example, we have an array. We have an array like that. Sorry. We have an array and we have a target number, which would likely find a target. So we need to find a sum of 3 elements which are the most closest to the one. Here is output is 2, because if you sum up -1, 2, and 1, it would be the most closest absolute in absolute to 1. So you need to find the most closest sum of 3 of any 3 elements which equals 1.
Substring, you mean?
No.
Not substring, but some subsequence.
No, just sum of 3, which not subsequence. It could be any numbers in array which are closely to target, which are the most closest to target.
Okay, I should choose elements from the array, and some should be closest to the target. Why it not will be, and why it will be 2? Answer is it what? Is
sum.
Is it why it will not be only one element 1?
No. The answer is a sum of the 3 of the 3 different elements which sum mostly closely to the target.
3. So example, I should always sum 3 elements.
Yeah, the answer 1 because -1 plus 2 plus 1 is the most closest here.
Yeah, I got it. So I should need to find triple triple of values from array that will be closest to my target.
Yeah, the sum of the triplet which closest to a target.
Got you. Okay, cool. So
let's
like
add another
why
example.
answer is 2 here? Because answer, if I will sum these 3 values, it will be 0.
Yeah, because
no, it's 2. Yeah, right. Sorry. Yeah, my fault. Yeah.
Yeah, because if you add here, just it is in absolute value.
Yeah, I got it. Yeah. Even it's my fault. Sorry. Okay, in this case, answer will be 0 because I'm summing all three elements, and it will be the closest one, right?
Yeah.
Okay, cool. And it's not sorted, as I understood.
Yeah, it's not sorted.
Okay, cool. Let's think. And we need to have closest. First thing that comes in mind is sort this array. Will it help us if I will? No, yeah, I can do it. So -4, -1, 1, 2. Can it help us? I have target. Interesting. Okay. First of all, brute force solution. We can find all 3 possible triplets, also possible values, and compare it with final target. So it will require us 3 loops, 3 for loops, and we will find the minimum difference between target and our triples.
Yeah.
So time complexity of it will be O of n power 3. So can we do better? I think we can. I think if we can do, I think we still need to sort it. It will help us. And so we can iterate for each value. And so if I will choose one, let's say we have sorted list. It will be -4, 2, 1, and -1 here. So let's say we're iterating 1 by 1 for here, and then we need to find 2 values. So basically, in the start we have -4. Our target is 1. So let's say, and from this moment we need to find pair of value. Let's say, so let's think about it a little like that. That we have target and we don't need to close it, but exactly this value. It will make a little simple, and then we can find improvement. So if we want to have target of 3 values, so we choose -4, we can sum it with 1. It will be -3. So it means we need to find 2 values that
just one value because you have a triplet.
No, target is the one. Target, I mean, this one is I already choose from our list only one value, -4.
Okay.
And we have target, we summed it, and so we need to find -3. As I said, we already sorted. It will take us n log n time, so it will not make sense not big deal for us here. So we need to find values closest to -3. Not to close it, equals to -3. So we can take 2 pointers and do like window how to say, window iteration. We have 2 pointers. One will be on the left one, on -1 in our case, and it can be so let's say here it will be left pointer, and right will be there. We see that -2 plus 2 will be 1. We understand that it's bigger, so we need to move our left pointer. If our left pointer reached, it means so in our case, it's actually it means we don't need to go further. We already find the closest value because it's like if minus value, we can do better.
Yeah. There's no minus value.
Okay, cool. In case if we can do better, let's say it will be -2 here, and it will be -1. So it will be -3, and we'll already find it. So also not really good explain. Let's say it will be -3, and it will be -1. And we need to find closest to absolute value. It can be 3 or -3, right? Okay, so
it has
3.
3.
So it can be 3. So we need to check if it will be minus or plus. So we need to find 2 possible. We need to consider 2 conditions. One, if our triple will be -3 or our triple will be 3. And once we did it, if we found, we need to update closest. So I think I have idea how to implement it. Can I start coding? What do you think?
Yeah.
Okay, cool.
But
so
about time complexity,
yeah,
in my opinion, if you would like to use 2 pointers, yeah, I understand you, right?
Yeah, in this case, it will be O n square. It will not be n, because we don't need to do 3 loops. We just need to do 2 loops.
Yeah, because you write here 3 and
yeah, it was when I discussed brute force solution. So yeah, our algorithm will be on square. Yeah. Okay, cool. So I'm going to implement it with Java, if you don't mind.
Okay, no problem.
So we need to return int, public int, and we need to find closest sum, closest triple sum to target. Okay. What we have in input, we have our integer list. It will be our list. How can we name it? I don't know. List.
Let it be nums.
Okay, let it be nums, and our target in target. So we are going to iterate it for int, let's say int size will be nums length. If e from e less than size I plus plus. So we are going to iterate it through each value. Yeah, I also forgot that we want to sort it, to sort our array. Also, we can check here that if size less than 3, we can return -1, I think, right?
Yeah, let's be -1.
Okay, cool. Like that. And if, yeah, okay, let's leave it for now. Size, even not size, but size minus.
Oh, it doesn't matter because, yeah,
something like that, because we so in case we have 4, it will be no. In case we have 3, yeah, right. Sounds good. Okay, so
Especially,
first, yeah.
Sorry for interrupting,
Sure.
but you should iterate all over array. For example, if you stop here, your left pointer could be. So in my opinion, you should run through the whole array. However, you run here from the from the left to
I want to do it like
the
that
second from the end.
because we don't need to consider 2 last elements because we did it in previous iteration. So for example, when we start in case we have size 4, if we already we checked with 0, so we will consider our 0 element, first element, second element, also 0, first, third element, and 0, second, third, right? And when we go to first one, we already so our only solution is 1, 2, 3.
Oh, okay, yeah.
Okay, so in first will be our nums e. So we took it first, and also int target. No, target we already have it. How to say t sum? Let's say target sum. Target sum will be our plus minus. How to say it? How to do better? So we want to sum, right? We want to sum them.
Yeah.
So we are summing, so we need to do first minus target. Okay, so then we need our 2 pointers and left pointers. It will be on 0 on I plus 1 and int, let's say left, it will be more visible. That and right, I plus 2.
So my question is, if it is if you choose 2 pointers, yeah, why choose the rightest element equals plus 2? Just index from the index of our first element, the right element is just plus 2 by index. However, in 2 pointers, oftenly we choose the most rightest, like the end of the array.
We can do both, I think. So let's think about it. In our case, -4, 3, -1. We can I think so. We choose -4. Let's say if R will be here. We can do both. It doesn't really matter, but we can, if you prefer to use this method, so our right iterator will be decreasing and left iterator will increasing until we will not find the match. Yeah, we can do also like that.
Yeah.
So we always update. Yeah, let's do it like that. No, doesn't really matter. So it means our right will be our size -1. And we do our while loop, left less than right. So if we even don't need target sum, I think we can just sum first left and right and check check closest to it. I think
in my opinion, we should hold the difference between the target to iterate over to change left or right pointer, in my opinion.
You mean to keep target sum?
No, to keep to keep an sum of triplets and difference between sum of triplets and target.
Yeah, that's what I want.
We should
let me show you. So if our first plus, not even how to do it better. I think we can do. So first of all, I forget about answer. Let's say int ans equals on I don't know. What can let's say integer max value. We will do like that. Answer will be left our first plus nums left plus nums right. So we are summing it and we want to minus target. Let's add brackets so it will be more visible. And we need absolute value, right? So we need to find integer mean our answer with first nums left minus target, and it should be absolute mass abs. Okay, let's check our brackets so and make it more visible. Months abs. Okay. This one. Up. Abs.
In my opinion,
yeah,
we should to understand which pointer to make bigger or smaller. So
yeah,
if
we will do it. We need to do it.
Okay.
So now we update it. It doesn't really matter. If it will not be smaller, we will do it. If not, it will remain the same. And then we need to update our pointers. Now, yeah, this is also the question. Okay, I think we can not update answer here. We need, let's copy it. Let's name it int diff equals mass apps. So we have diff if our diff bigger than what?
Answer.
Yeah, right. Bigger than answer. So we want to decrease it. So we want to write -1. We want to change right pointer.
Okay.
Else, no, even here, I think we also can do like that. If diff, no. Can diff be equals to answer? It doesn't matter for us. Actually, we can do it.
Matter
we can
because
break even.
Oh, okay.
We can break, I think, here because let's think.
I think we could decrease if it's equals because because you need to
It's
not make
yeah,
endless
right,
loops.
right. Okay, cool. Left plus plus, and we're updating into answer here, answer and diff. Here we return our answer. What do you think?
Yeah, I think it's clear.
Okay, cool. So our solution doesn't require any additional. I can do debugging on our example line by line if you want. Do we need, if we want? If not, you can share your thoughts.
For me, it doesn't important because the show debugging in notebook is like,
yeah, I mean debugging.
It's like strange thing.
I mean implement debugging, so we'll make sure that we didn't do any bug. So only for this case. If you think it's clear, I think we can finish here. Or you have any additional question from me?
I could.
I meant not question
just...
in a new question. I mean regarding this task.
Oh.
Yeah, I'm here.
Yeah. Oh, you haven't initialized in the beginning the different. Oh, you haven't initialized. Yeah. Sorry.
It's here.
Yeah, I think it's quite clear.
Okay, cool. Let's jump to feedback. You can share first of all your feedback, and then I will share mine.
Yeah, about the feedback, especially it was a task with quite, it was with pattern, so it's good that you write about brute force solution, because we need to compare two solutions, ours and brute force, how it's better with the space and memory complexity. So it is good that you draw, not to draw, like trying to visualize a result, and because it would help me as a reviewer, and help you as a people who is reviewed to understand the solution of that problem. So as for me, it is quite clean code, no mess. It is good. It is easy to read and to understand the logic. So maybe the worst case, it was not to explanation the bad things. What was with interview?
Explanation about what?
You just forget to mark down where the about complexity and something. So sometimes you forget about small things such as matching, for example, like with equals or not equals number.
Yeah.
If it's
okay, got it.
If it's strictly, so it's just a small things. Yeah, but as for somebody, it would be really important that you didn't forget about it. Yeah, and from it was like not a mess. You not understand the core solution. You have just a of its solution. At the end, you will also understand that you have
I didn't
complete the solution.
because of connection. I'm not sure it was my connection or yours connection. Can you repeat last point? Still not hear
Last
you.
point, it is about that at the beginning of the interview, you're not quite understand how to find a solution. But it's good that you also with the thinkings and cooperating with me, that cooperating also help you to find a solution. So at the beginning, you was likely not confident that you that you have a clear solution right now or something like that. Just you need a little bit of time to think.
Before coding, or you are
Before
talking
coding,
about
before coding.
before
coding.
Okay. Regarding this, I can tell that I wasn't quite familiar with this exact question, so I tried to share my thoughts how to solve this problem. That's why if I didn't see this question before, it's really hard to jump exactly to right solution. So it was like think processing.
Yeah, it's okay.
Gotcha.
It's just remarks. I think it's not an error or something bad. It's a remarks that I have find in interview in reviewing interview.
Got it. Okay, cool. Let's jump to my side. I will also wanted to tell you about you how interviewer. I want basically everything is great. I have it was a nice experience. I want to just tell you some remarks regarding. So I feel like question on the start was like a little bit not clear for me. Maybe probably better to write it down. But then we cooperated and found what actually we want to do. So that it's just like my thought, but it doesn't really. It's not a bad or good thing. It's just what I felt, and I also felt a little bit like so during the coding, you're like all the time with me and trying to help me to code. So I think as interviewer, not for me, it was right. It was great because it really helped me a lot. Even if but I felt that you're trying to help me to implement a solution that you already know. And it's like when I stop for in some place or I don't know. So you give me lots of tips during the coding and it doesn't help you to value me. So it's not only me coding, it's also you coding. So your scoring, your final score will be like not only my experience in coding, but also yours. But it's okay.
I try to give a question that you think about to making next solution because you try to make it fast and also you miss some things. So I just try to give a question. So you
I just wanted to tell that maybe better to give interviewee to find his mistakes when he implemented it. Then he want to test it somehow and check himself. So maybe he will find the problem that he has. So maybe he will do additional tests. That's why I'm trying to code fast because I want to save time to test it and do review before I'm giving you final solution. So that's why. So you tell me on the fly what I missed, but maybe I will find it in the future. So you like marking me that it's a bad thing, but actually I just didn't return it. So it depends on interviewer, but I feel like that. So this is my view. So maybe it will help you in next interviewers also. Regarding my question and your turn as interviewer, I think there is a little bit confusion in the start, but finally we understood each other. So I wanted to mark that I little bit confused regarding naming convention. It doesn't really really bad thing, but so find right. it doesn't really clear for me. So for example, in production code, you should understand that, of course, it's not production code, it's whiteboarding, etc.
Yeah.
But you still need to keep it cleaner, or even if you name it like find right, just mention that it's not really good naming. In production, we will change it, but we want to save time, so let's leave it like that. This phrase is very nice. It doesn't takes a lot of time, and interviewer will understand you. But even on real interviewer, sometimes they say no. Let's name it as it should be. Sometimes interviewer really value it, so keep it in mind. So find right is not really good. Tree also, tree we don't really it's actually our node. We can name it root or current node, but also okay. What else regarding space and time complexity? I tried to ask you before, but we somehow didn't touch it. You didn't answer. I didn't get catch it how it happened, but it doesn't matter. Then we discuss it later. Basically, I think it will be better for you to check how time complexity and space complexity works in tree and graph questions. I think you're a little bit confused in it, because for here we actually we iterating through each node, and there is no counting. It's binary tree node, so you have always maximum two branches. So in this question, you don't count it. So it will be always you iterating through each node. Even you have null branch, you will iterate it. So it will not count like branches. So it will be only OFN. And also about time complexity, you decided to store all your nodes. So you will store only nodes. So you time complexity and space complexity, usually in binary tree, it will be O of n or O of log n. So this is like tip, but I think it will be good if you will refresh your memory about it. Regarding coding, I think we have messed a little bit here.
Yes, a little bit.
So also, yeah, it's a little bit hard to explain my expression, but I felt like I didn't get your explanation. So probably I think as interviewer, I will mark it that you didn't share your thoughts clear, so I will understand it. It's of course it's very personal thing. So maybe I'm stupid and I didn't understand. This is one thing.
No, it's
yeah, I understand. No worries. But yeah, so explanation can be very little bit clear here. I think you changed code several times on the fly, and it also adds confusion. Also, you should be very clear about what the data structures you are using. In our case, it was sometimes array list, then two-dimensional list, and then it was hash map, and then we decided to went back. So this was not really good. And in terms, so I asked you about space complexity, but you tried to use hash map. Hash map only helps us to decrease time complexity, but in our case, it also doesn't work. So try to make it. I understand that it's a little bit nervous. It's not really common thing to do mocks and interviews, but try to stay clean on these points. What else I can tell you? Yeah, regarding coding, I think I see you can code, of course, but it looks like you already have some thoughts about how to implement it, but it wasn't finally clear for you how to implement it, and whole algorithm wasn't finally cleared. And I think this is a problem. This is always a problem when you so you think you know how to solve it, but on the fly you're trying to change your thoughts, you have new ideas, and it will make you do some mess. So this is a problem on all interviewers, I think, and this is harder thing to do from my point of view. Yeah, and one last thing that I wanted to mention, when you tell me something. As you see, we have two lists, not two lists, two blanks, two whiteboards, and sometimes you jump to the start and jump to the down, but I was there, so I don't see what is happening here. So when you are jumping and trying to explain something, just tell that I'm on page 1 currently. So let's check this page. This is my items. First of all, thank you very much. It was really nice. Thank you for the question. And good luck to you.
Also good
do
luck.
You have any? Thank you very much. Do you have any additional thoughts? How was it for you? How was mock?
Yeah, for me it was quite interesting. So yeah, I understand. Yeah, I have problems that I'm jump from one floor to another. Yeah, it's not quite it's not quite good because just it creates mess, how like that. So yeah, as for me it is really important to make something with someone with me also as interviewer and as interviewed. So yeah, I think it was quite interesting. Yeah. And I have solved look-alike a task which looks like SEO with trees, but not like that. Yeah, so it was like
it's also nice. So I found the right question.
I was a little bit unconfident.
Got it. So yeah, so of course it's all about practice, and all that. Even you have 500 solved questions, it's always possible that you will get on real interviewer questions that you don't know, and you will need to figure out how to solve it. So that's why we are doing mock, so it will decrease our chance to fail. So thank you very much, and good luck.
Good luck. Bye.
Bye bye.